and welcome to my channel. As you all know, this is all about community medicine, and this is Professor Dr. Aditya Aikar taking you through one very interesting upload on basic statistics. Statistics, whenever you come across this term, often people find very uncomfortable with it and think that it is a lot more complicated than what actually it is. So today what we are going to do is take up a very important part of the statistics, that is the sampling and its various aspects, and try to understand in simple terms. So these particular part that we will be dealing today is belonging to the Competency CM 6.4, that is about the enumeration, discussion and demonstration of common sampling techniques. So the questions from this sector may involve like what is sampling, what are the different sampling methods, mention the advantages, the disadvantages of each method in the form of long question, or there may be short notes like types of sampling or just sampling, or difference between the different types of sampling. What we understand when we see statistics? Well, different authors have defined statistics differently. Some have put it up as the science which deals with the collection, presentation, analysis and interpretation of the numerical data, while others have put it up as a science and art of dealing with variation in data through collection, classification and analysis in such a way as to obtain reliable results. Well, this is as per John Last. As you know, John Last is the one whose definition of epidemiology is the go-to one. Some also puts it up as a branch of mathematics that deals with the collection, organization and analysis of numerical data and with such problems as experiment designs and decision making. But I guess the last definition, that is by John M. Last, is more appropriate concerning statistics. Statistics in fact is very different from mathematics in the sense mathematics is an accurate science. You deal with accuracy. 2 plus 2 is always 4. It cannot be 5. But statistics is little different. It's a science of probability. That it may be so. And how and to what extent so? That is the job of statisticians. Now coming to biostatistics, that is the medical statistics. It is defined as the application of statistical methods to medical, biological and public health related problems. It is the scientific treatment given to the medical data derived from a group of individuals or patients. It involves the collection of data, presentation of the collected data, analysis and interpretation of the results, and of course, making decisions on the basis of such analysis. The crux of the whole issue is, if a population is completely homogeneous, supposing we all have the same age, we all have the same height, we all have the same face, we all have the same biology, there is no variation, then there is no need for statistics. Statistics is the branch of science that studies into the variations which happen within us and around us. So what is this sampling? So if you look at the definition part of it, it's put up as the scientifically accepted method of selecting observations from a lot or group. So if you take this bigger circle with multitude of figures inside as the population, selecting some from that bigger circle into a smaller circle is the sample. That is looking at a small portion of the entire population. And the sample should be such that it represents the whole population. And its purpose is that through studying that smaller population, you can draw a inference which you can generalize on the rest of the population. So let's try to understand in an even more simpler way. So what do you see here? There is a cooking utensil meant for cooking rice. Some rice, and in the adjacent picture you see that someone is mashing the rice to check if it is cooked. If you ever noticed at home, you will see the person who is cooking doesn't check every rice in the utensil. Takes out with a ladle some bit of the rice, mashes probably a grain or two, and if it is well cooked, decides the whole pot is well cooked. So based on that ladle full of rice, inference is drawn that the entire pot of rice is well cooked. That is a everyday sampling we have at our homes. This whole pot of rice is the population. The ladle full of rice that we take out to check is the sample. And the mashing that is being done, that is the testing carried out on the sample population. And the conclusion that we are drawing and deciding that the entire pot of rice is cooked is generalizing the result we got from that ladle of rice. So the sample means it would be so that if you put 2 pots of rice, it may not be cooked at the same time. So the sample means of 2 different samples, A and B, may be different, maybe just same. So if you look at the sample universe, the top circle, it is the population which is a set of similar items or events which is of interest for some question or some hypothesis that has been generated. A statistical population can be a group of existing objects or a hypothetical and potential infinite group of objects conceived as generalization from experience. Now is the sampling frame, the next round. It is the source material device from which a sample is drawn. It is a list of all those within a population who can be sampled and may include individuals, households, or institutions. And sample is the final round, which is a set of individuals or objects collected or selected from a statistical population by a defined procedure. The elements of a sample are known as the sample points, sampling units, or observations. So let's try to understand in terms of an example. Supposing we decide to carry out a study on the medical undergraduate students. So if this is the population, and then we choose the sampling frame as all the students doing undergrads in the medical colleges in West Bengal. And then I decide that from this sampling frame, we will choose our sample. So let's look at this. Here, the brown colored rectangle represents the target population. It is a set of units of interest on which we will be generalizing the result we get from the studying the sample. And B, that is the blue colored oval shape, is a subset drawn from the frame. And C is the non-target sample, which doesn't belong to the target population but is part of the sampling frame. The blue rectangle is the sampling frame, that is the reference set of units to be sampled. So the B is drawn from the sampling frame, which has some non-target sample and some target samples. And E is the methodology adopted to get to reach the sample from the chosen sampling frame. There is a sampling design. And F, that is the man in question standing over there, is the sampling unit, the item to be measured. So when we discuss about the difference between the population and the sample, what it is, let us look at it more objective fashion. In population, the measurable quantity is called a parameter. In sample, the measurable quantity is called a statistic. So P for P and S for S. The population is a complete set. Sample is a subset of the population. Population reports a true representation of the situation, and sample reports have margin of error and confidence interval. We will be discussing these basic things, that is margin of error and confidence interval, in details in the time to come. So it contains all members of a group in a population, but sample is a subset of the entire group. The population mean is represented by the sign mu, and sample, it is represented by x bar. Now why we need sampling? Because to do a study on the entire population is restricted due to a lot of constraints. There may be shortage of resources. We would need detailed examination of so many people. So sampling helps us by optimizing the resources, helping in detailed examination of smaller units, smaller population to cover, and reasonable estimates of parameters required in short time, helpful when units of area are homogeneous in nature. So why does sampling work? Because we can generalize it on the target population. The same way we generalized our result that from a ladle full of rice that the entire pot is cooked, in the same way we get a result from a sample that is representative enough to generalize the inference about the target population from where the sample is taken. So understand the population, the steps we follow are: we select a sample from the population, measure certain data or an opinion for all individuals in the sample, and project the result we observe in the sample onto the population. This projection or extrapolation is called generalization of result. So this generalization adds a certain degree of error to those results, because when you are making an inference based on only a part of the population, it will tend to have some error. Let's imagine that we asked a random sample of 1,000 Indians if they smoke, and 25% say that they do. We presume that we would be getting about the same result we asked all Indians. Is it true? It may be true, it may not be true. It may be so that the result is underrepresenting the actual percentage of the population. And it may be so that it is higher than the actual. So generalization of results from a sample means accepting a certain amount of error. So what is the sampling process? First, you define a target population. Then you select a sampling frame. Then from that sampling frame, you adopt a sampling method, plan the sampling unit selection, determine the sample size, and conduct the study on the sample. So in this process, as we said, that it involves a lot of errors. It could be population specification errors, there could be selection errors, there could be sample frame errors, or there could be sampling errors. So coming to the different types of sampling methods, it can be probability sampling and non-probability sampling. Probability sampling are those where quantitative research designs are mostly carried out. These are named so because the investigator knows the probability of the sampling unit entering in the sample because it is pre-decided. And in the non-probability sampling, the sampling methods are used mostly in qualitative methods of research, and it doesn't follow a very typical method of selection. So in the sampling method, in the probability sampling, we have simple random sampling, stratified random sampling, systematic random sampling, and the cluster as well as the multi-stage sampling. In the non-probability sampling, we have convenience sampling, purposive sampling, quota sampling, and snowball sampling. Let's have a look at each of these. Firstly, let's understand the simple random sampling. See, in the simple random sampling, what we are doing, we are having a population. From that, randomly, we are choosing the required number of sampling units. Here, each and every units in the population have equal chance of being selected in the sample. So, what are the steps in this simple random sampling? First, you enlist all the sampling units. So, we, for example, make a list of all students who are eligible to enter in the list as per the inclusion or exclusion criteria. Now, the next step is deciding the sample size. For this, let us suppose it is 100. Now we have to adopt a method to get those 100. And this can be done in 3 methods in the simple random sampling. Firstly, the lottery method, then the use of random number table and the random number generators. What is the advantage of this method? This simple random sampling, the sample is representative of the population because equal chance is given to all the population being, units in the population being selected. The population estimate is easy to calculate. The disadvantage being, if the N is very large, this method of sampling is impracticable and there is larger risk of random error. Now coming to stratified random sampling. As you can see in this picture, supposing in a university, different female students have come from different countries and are studying in an international university. So, if we take a random sample from that, it is possible that not all the races will be equally represented. But if we make a stratification, that we will take a certain percentage of the Europeans, certain percentage of the Asians, certain percentage of the Africans, and so on, depending upon the weightage of the different strata. If maximum number of students are coming from the Asian origin, then the strata will have greater weightage from the Asians. So here, as the populations are divided into different groups, each groups are called strata, and subsamples are randomly selected from each strata, and the elements within a stratum should be as homogeneous as possible. So when we were discussing in the previous example, so when we are taking the sampling units from the Asian strata, it is preferred that it is composed of mostly in fact all Asians. So but elements in different strata should be heterogeneous as possible. That is, there should not be Asian in the African strata. And when we are making strata, the classification should be separate with as much less overlapping as possible. What is the advantage of this? It assures representation of all groups in a sample population. Characteristics of each stratum can be estimated and comparison can be made between the strata also. The disadvantage is it requires accurate information on the proportion of each stratum. And stratified list is actually at times time consuming as well as costly. Now coming to the third one, that is a systematic sampling. Here we follow a typical rhythm to choose the sampling units from the sampling frame. Supposing we decide that from 1 to 100 there is student, and from that every nth student is taken. So this is following a system. So order all units in the sampling frame and then every nth number on the list is selected. If k is the sampling interval, capital N is the total size of population and small n is the proposed size of sample, the sampling interval is k by capital N divided by small n. The advantage is moderate cost, moderate usage, simple to draw sample, easy to verify. But the disadvantage is period ordering is required and carried out in stages using smaller and smaller sampling units at each stage. Now let's come to cluster sampling. Cluster sampling is basically looking at groups that are naturally occurring. They are naturally part of that geographical area. More like families. A simple random sample is then taken from each of those naturally occurring clusters. A special form of cluster sampling called the 30 cluster sampling has been recommended by the World Health Organization for field studies in assessing the vaccination coverage. So in this list, what is done, all villages or clusters for a given geographical area is made. And 30 clusters are selected using probability proportional to size. So from each of the selected clusters, 7 subjects are randomly chosen. And thus a total 30 into 7, 210 subjects are chosen in the vaccination coverage. So here we see in the population, we found 6 naturally occurring clusters. And from that, we decided to choose the cluster number 1 and cluster number 4. And from this, we will choose our sampling units. So what is the advantage? The sampling frame is not required, and in practice, when complete lists are not available, can estimate the characteristics of both cluster and population. Disadvantage, the cost to reach an element to sample is very high, and each stage in cluster sampling introduces a sampling error. The more the stages, more the error. So in this context, it would be good to understand the difference between cluster sampling and stratified sampling. Cluster sampling is where the members of the population are selected randomly from a natural occurring group called clusters. And stratified random sampling, the population is divided into homogeneous segments depending upon the research question, and then the sample is randomly taken from the segments. And all members from the divisions naturally formed in cluster sampling, and in stratified sampling, randomly selected members from the strata. Cluster sampling involves more errors, reduced cost, and stratified involves reduced error but increased precision. Clusters are heterogeneous in nature within the group. Strata are homogeneous in nature within the group. Clusters are homogeneous between the groups, and strata are heterogeneous between the groups. Multi-stage sampling. Well, multi-stage sampling is actually thought to be an extended version of the cluster sampling. It is carried out in stages using smaller and smaller sampling units at each stage. And what are its advantages? More accurate, more effective. And the disadvantages that it is costly, and each stage in sampling introduces sampling error. The more stages there are, the more error there tends to be. So let's get a good recap. The first picture is about simple random sampling, where you can see there's a population and we are randomly selecting some sampling units. There is a systematic sample in the top right picture, where we are following a definite sampling interval to choose our sampling units. Then in the bottom left, we have the stratified sample, where we are distributing the population into 2 distinct strata and then randomly selecting the sampling units from each of these strata. In the cluster sampling, we see they are in a definite geographical area. We are letting them be as they are and then randomly selecting from those clusters. Now let's have a look at the non-probability sampling. The first one to discuss is the convenience sampling, the selection of whichever individuals are easiest to reach. Supposing I am conducting a survey among the medical undergrad students, and I call those students, girls or boys, with whom I am comfortable, and I have 1:1 equation. Why? Because I feel it is convenient for me to gather the data. So it is done at the convenience of the researcher. used in pilot studies because it allows the researcher to obtain basic data and trends regarding the study without the complication of using a randomized sample. What is the advantage? It is fast, it's inexpensive, it's easy, and subjects are readily available. Immediately known population group and good response rate because you have a convenience with them. Disadvantages, sampling error are strong because you may be taking a very biased take on the population. Sample is not representative of the entire population, cannot generalize the findings to the population. Now coming to the purposive and selective sampling, what it is. This is a sampling technique that qualitative researchers use to recruit participants who can provide in-depth and detailed information about the phenomena under investigation. It is highly subjective and determined by the qualitative researcher generating the qualifying criteria each participant must meet to be considered for the research study. Supposing I want to study the adolescent health program and problems in a rural community. Well, obviously, for this purpose, I will select the adolescent members of the family when I am visiting the community. Why? That is being purposeful because they are the persons who is my point of interest. So what is purposive sampling? Advantages, it is based on the experienced person's judgment. Being a researcher for a long time, I know that to get this particular study, I need to focus on those adolescent groups. So that is based on my judgment. And what is the disadvantage? It cannot measure the representativeness of the sample. Now, snowball sampling. This is a technique where existing study subjects are used to recruit more subjects into the sample. Supposing I am comfortable with 2 or 3 girls in the class. And I call them and I tell them, please send your friends who may be interested in this for carrying this out. They bring each of them 2 or 3 more. Maybe those I don't know directly, but because they are familiar with the girl whom I had sent, they come to me. And eventually, when these girls come to me, I tell them to bring some more. And they bring more. So this way it is happening that the snowball is rolling, and as it's rolling, the sample size is increasing in size. What is the advantage? The chain referral process allows the researcher to reach populations that are difficult to sample when using other sampling methods, cheap, simple, cost efficient. And disadvantage, little control over the sampling method because I don't know who they are going to bring up. It is for them to, refer and bring. Representativeness of the sample is also not assured in this case. Now coming to quota sampling, it is described as the non-probability equivalent of the stratified sampling. In this method, the researcher creates a sample involving individuals that represent a population. And the researcher chooses these individuals according to specific traits or qualities. They decide and create quotas so that the market research sample can be useful in collecting data. Supposing from this population, I'm looking for information about male above 40. So I create a quota for these and collect my data from there on. Then you will ask me that since you are forming a separate group, why it's not a cluster sampling equivalent? Because this is not a naturally occurring group that I am making. I am making a strata because or a quota on which I can make my study and the objectives are met. But why it isn't then stratified sampling? Because the way I choose from this quota is not random. It will be selective. The disadvantage is because this can be selectively chosen from that quota, it can be unreliable. It mostly relies on the researcher's subjective judgment in choosing the right subgroups and giving them the right weightages. And the results cannot be generalized and is non-representative of the entire population, unlike a random sample. That is where the stratified random sampling is superior. Its advantages, it contains specific subgroups in a desired proportion, and of course that gives them ease of management, quick to carry out. Now let's see some terms that we need to know and that are important from the point of view of sampling. Firstly, random error. These are errors that occur by chance. Sources or sample variability subject to subject differences and measurement errors. This can be reduced by averaging, increasing the sample size and repeating the experiments. So here what happens in this random error, each and every unit has equal chance of being subjected to this error. Now coming to systematic error. If you go in my previous video, you will find a detail about this as I talk about systematic error, that is bias. Here the deviations are not due to chance alone. Here it is part of the system and it is usually reduced by good study design and conduct of the experiments. Now coming to the third term, that is precision. The degree to which a variable has the same value when measured several times. It is a function of the random error. So what is accuracy then? It is the degree to which a variable actually represents the true value. It is a function of the systematic error. So let's get a very clear idea of the difference between accuracy and precision. So look at the first one. The black dots are right on the center and closely placed. Because the objective is going to the center, they are accurate, that is, they are measuring what they are supposed to. If each of the 4 dots have fallen on that same place, so all the 4 observations on repeating has been on the same place, so they are precise. So this result is accurate and precise. Coming to the second one. Here the dots are quite close, that is, every time the results have been carried out, they have been similar, but they are far away from the center, so they are not accurate. So this result is not accurate but precise. Now let us look at these. These are mostly around the center, but the points are far apart, that is, the values are not repeated in a similar way. So the result is accurate but it is not precise. Now let's look at the fourth one. Here we see the dots are apart, far from the center, and what does that imply? It means that it implies that it is not accurate and not precise. So that is a visual impression to get to understand that accuracy and precision are not the same thing. So some other important terms that you should be knowing regarding error is type 1 error and type 2 error. Type 1 error is largely known as the alpha error. It is equivalent with the term level of significance of a test. That is, the rejecting a null hypothesis when it is true, and it is usually fixed before the testing of hypothesis estimation and sample size calculation. In a standard situation, the probability can be taken as 0.05 or 0.01 depending upon the study. So the alpha error is about when you have presumed a hypothesis and in reality also it is true, but due to error in your study, you have rejected the null hypothesis. So this is the level of significance attached with the study. Now type 2 error is the beta error. It is accepting a null hypothesis when it is wrong. Supposing the hypothesis you had presumed was wrong and you are still accepting it based on a study design. So that is committing a beta error. Now coming to power. What is power? It is 1 minus beta. That is the probability to reject the null hypothesis when it is wrong. So for a good study, one should have to take at least 80% power. An increase in the sample size or a greater difference between the control and the test groups leads to an increase in the power of the test. So what is confidence interval? The probability that an estimate of a population parameter is within a certain specified limits of the true value is usually calculated by 1 minus alpha error. And margin of error is the degree of error in result received from the random sampling. It tells you the range of values that fall above or below the chosen confidence of interval. Now let's try to understand in terms of an example. Supposing a poll might report that a certain candidate is going to win an election with 51% of the vote. And they say the confidence level is 95% and the margin of error is 4%. So what do they mean by that? This means that if the poll is conducted or repeated in the same area 100 times, then out of that 100 times, 95 times, they would expect the results to vary between 4% of the stated result. That it could vary between 51 plus 4 or 51 minus 4%. That is 47% and 55% in the said example. So the margin of error can actually be calculated in two ways, depending on whether you have a parameter from a population or statistics from a sample. So it is calculated by multiplying the critical value with standard deviation for the population and multiplying the critical value with the standard error in case of a sample. So what is the importance of this critical value? This critical value is actually extremely important in terms of evaluating validity, accuracy, and the range at which errors or discrepancy within the sample set can occur. This value is an essential factor in calculating the margin of error, as you can see. It can also give us an insight into the characteristics of the sample size that you are evaluating. Now, coming to the sample size estimation, one has to identify the major variables, determine the type of estimate that is either proportion or mean, then expected frequency of the factor of interest, the desired precision is to be decided, the acceptable risk to be decided, and then the risk of estimate falling outside the real value. And then one has to adjust for the population size, the design effect, and the expected response rate. If the sample size is too low, it may fail to answer the research question adequately and may fail to detect the association or associate imprecisely. If it is too high, it is usually difficult to conduct, very costly, and obviously there is a big time constraint. There are various formulas based on which you can calculate the sample size. Although it is beyond your undergrad scopes, still it is good to know that when it is based on mean, the formula is n is equal to z square multiplied by sigma square divided by d square, where z is the statistics for a level of confidence. So for the level of confidence of 95%, which is the conventional one, the z value is 1.96. And sigma is standard deviation, that is, and d is the precision. D is considered 0.05 to produce a good precision and a smaller error of estimate. Now when it is based on proportion, that you have only the prevalence or something like that, then the sample size is calculated as n is equal to p into 1 minus p multiplied by z score divided by d square, where again z is the statistics for a level of confidence, p is the expected prevalence of proportion, and d is the precision. And when we are comparing two proportions, then n is calculated as p1 into 1 minus p1 plus p2 into 1 minus p2. And this whole summation is multiplied by z alpha by 2 plus z beta whole square divided by p1 minus p2 whole square, where n is the required sample size, p1 is the estimated proportion of study outcome in the exposed group, p2 is the estimated proportion of study outcome in the unexposed group, alpha is the level of statistical significance, and z alpha by 2 represents the desired level of statistical significance, and z beta represents the desired power of the study, and typically it is 0.84 for 80% power. And for each group multiplied by 2 is the total sample for the two groups. Hope you had a fair understanding of the basic concepts of sampling. What are the different types of sampling? What are the advantages? What are the disadvantages? What are the important terms to know in context of sampling? What are the differences between the different types of sampling? As well as how to calculate a sample size and what are the steps involved in it. So if you like the content, please do subscribe to my channel, put in a big thumbs up and press the bell icon to ensure that every time I upload an academic content, you are the first one to know. Thank you so much. Stay happy and blessed and keep studying.